So students, we're going to talk about a specific type of function called an absolute value function. And you've seen this before in Algebra 1, but just to remind you a little bit of what absolute value is, you might have seen, remember the little bar notations that go around a number like this. And remember, absolute value means whatever result you get inside the bars comes out as a positive. Absolute value means the distance from zero. The distance from zero. And so that's why it doesn't matter if you're on a number line and here's zero. Let me finish writing that out. The distance from zero. If you're at a +5 or a -5, either way, you are 5 units from zero. And that's essentially what absolute value is representing. So when we're dealing with the absolute value to graph it, in Algebra 1, you used y equals the absolute value of x. And now we're going to use function notation, which looks like f of x equals the absolute value of x. So this x is our input, and we input it into our absolute value brackets. The function of that is the y. So when we get our result, the function of that particular x will equal our y. So I want you to make a note of that. F of x is your y. They are one and the same. Okay? Now, to graph our parent function, what we're going to do is we're going to start at 0, 0. And I'm going to put 0, 0 right here, kind of in the middle. I want to go back to -1. I want to go forward to +1, 2, and 3. All right. If I plug in a 0, the absolute value of 0 is 0. So that's where this comes from right here. If I plug in a -1, I get out a +1. If I plug in a +1, I still get out a +1, a +2, and a +3. All right, now when I plot those points, I'm going to go to -1, +1, plot my point, 0, 0, 1, 1, 2, 2, and 3, 3. Now, think about this. If I were going backwards and went to a -2, I would get out a +2. It's going to reflect. It looks kind of like a parabola, but it doesn't have a curve. It meets at a point. Okay? So we have this different relationship. It's got a sharp point and not a turn right there. So this is what your parent function looks like. And remember, your parent function is the most basic, simplest form of that particular function. Your vertex is going to be where the two rays meet. So right here, our vertex is going to be at 0, 0. Now, our domain is all of our x values, okay? So all of our x values. So we can say, well, I can plug in any value from here to +infinity. I can plug in any value here from 0 to -infinity. So I can plug in any numbers into the form f of x equals the absolute value of x, and I'll get a result. I'm not limited. So my domain is going to be -infinity to +infinity. Now, my range is my y coordinates, okay? And I want you to notice on your y-axis, this graph never goes below 0. Since it never goes below 0, then what that means is your lowest point is 0, okay? And I'm going to draw an arrow going up like this. My lowest point is 0, and I'm going to put a bracket and a 0 right there. The bracket means 0 is a value that is included in my range. and then I'm headed up here to positive infinity. I put parentheses. Notice parentheses around my infinities. Infinity isn't a valid number. It's a destination. It's something we're approaching, but we never reach. So you never put brackets. You always put parentheses around it. All right. Now then, the next thing we're going to do is your maximum and minimum value. So our maximum and minimum has to do with your y coordinate. And now, since this is headed to positive infinity, going up, we have no maximum. We're headed to positive infinity. So I want you to write no maximum. You're headed to positive infinity. But your minimum value is at 0. Your minimum value is at 0 right here. So we're going to look at your y coordinate, or the y, your y coordinates, to find where your maximum or minimum is. So our minimum is going to be at 0. We never go any lower than 0. Your axis of symmetry. Your axis of symmetry is that line that separates your graph in half. So our graph right here, to separate it so that it always reflects around your axis of symmetry, crosses the x-axis at 0. So our axis of symmetry is a vertical line. And remember, vertical lines are always written as x equals, no y in it, as x equals. And since we cross the x-axis at 0, we write x equals 0. So think of it as the equation of a vertical line. Where do we cross the y-axis? What is our y-intercept? We cross the y-axis at 0, 0. Where do we cross the x-axis? Right here. We cross it at 0, 0. All right, so this is our most basic, most simple absolute value function, our parent function. Now, on the back side, we're going to look at the graph, and we're going to get this, we're going to pull the information from the graph of an absolute value function that's been transformed. So right back here, I want you to take a look. Notice that this vertex right here has shifted down to -2. All right, so our ordered pair is at 0, -2. You got to give me the coordinate for that. Our domain, well, we are using all possible x values. All x values can be plugged in and can be used, and I can find my range. So our domain goes from -infinity to positive infinity because it's continuing. I know you're saying it's going up, but in order to go up, it has to also go out. So it's going to positive and negative infinity for the domain. However, your range, if you notice, this is the lowest point. It is not going anywhere below -2. So we start at -2, and then we continue on up to positive infinity. Because notice our arrows right here, they're going up forever. So we're headed towards positive infinity for our range. We have a minimum value. It doesn't go below this point. And we can say our minimum value, if we just state, let's see how we did it over here. Yes, our minimum value, we just stated the y coordinate. The y coordinate is -2. All right, so the y coordinate is -2. So that's as low as we go. And then our axis of symmetry, runs right through here. It hits the x-axis at 0, so our axis of symmetry is still x equals 0. We didn't move off of that y-axis to have our axis of symmetry change. We cross the y-axis at the point 0, -2, and we cross the x-axis at 2 points. This one is -1, 0, and this one is +1, 0. Notice when we state our intercepts, if you're on the x-axis, your y coordinates are 0 because you're on the x-axis. And you don't veer up or down. If you're looking for your y-intercept, you're staying right here. So your x-coordinate is going to be 0 because you're not shifting left or right. So anytime you're doing an intercept, you should have a 0 for the other function, for the other coordinate. All right. The next one, our vertex right here at 3, -3. Oops, sorry about that. I put my bracket in the parenthesis in the wrong place. There we go. 3, -3, that shouldn't be there. Their domain, we're still branching out to infinity. That is not going to change. Our range, we start at -3 and we go up to positive infinity. So -3 to positive infinity. We have a low point, that's a minimum, and our minimum is at -3. Our axis of symmetry now. Our axis of symmetry moved. Here is our line that separates our absolute value graph in half, and we cross the x-axis at 3, so that vertical line is x equals 3. We cross the y-axis at, the y-axis up here, way up there, at 0, 6. And we cross the x-axis at 2, 0 and at 4, 0. So there's our two x-intercepts. We'll practice, we'll do one more. We've got our vertex. Now notice this has reflected and it's flipped down, so it's going to make some changes in here on some of our items. But our vertex is located at 1, 4. Our domain, we still are growing wider left and right, so our domain has not changed. Our range, now, our range, this is a maximum. Okay, we now have a maximum, and our maximum point is at 4. How we write our range, you got to be careful, because our graph is now headed down here to -infinity. And when we state our domain and range, we always go from least to greatest. Well, our highest point is at 4, so I have to put a bracket around the right side. That's my highest point. My lowest point is me heading towards -infinity. It has to be -infinity to 4. It must go from least to greatest. So state out here your domain and range must be stated from least to greatest. Okay, that is super important. Now, your axis of symmetry, it did shift. It's right here where x is 1. So our equation is x equals 1 for our vertical line, our axis of symmetry. We cross the y-axis right here at 2, so our point is 0, 2. And we cross the x-axis at -1, 0. And here at 3, 0. Our very last problem, our vertex, -3, -2. Our domain, negative infinity to positive infinity. It still expands left and right. Our range is headed towards negative infinity right down here. Okay, so we start at negative infinity, and our highest point, our maximum, is at -2. So we have a maximum of -2. So that maximum or minimum helps us state our range right here. Your axis of symmetry. Your axis of symmetry, it goes through -3. So x equals -3. Our y-intercept. Okay, we can't see where it crosses the y-axis yet on here. So what we can do is we can kind of look here at this slope. We can go down 1, 2, 3 over 1, down 1, 2, 3 over 1, and down 1, 2, 3 over 1. So if this is -6, this is -7, -8, 9, 10, 11. So we are going to cross the y-axis at -11. And our x-intercept, there is none. We will never cross the x-axis because it's been reflected and it's shifted down below it. So we will never touch that x-axis. All right. So to reiterate, remember, absolute value is a V-shaped graph with an absolute maximum or a minimum and an axis of symmetry that cuts it in half. And then your domain will always be negative infinity to positive infinity as long as our graph continues infinitely. All right, that's it, folks.